Why does everything feel lighter underwater? Is gravity weaker down there? Is the water somehow holding the object for you? In this video, we're going to dive into the hidden force that fights against gravity. Stay until the end, because once you understand this, you'll never look at water, swimming, or even ships the same way again.
Gravity, the force pulling everything down.
First, remember, on land, gravity is the main force you feel. Gravity pulls every object down toward the center of the earth. The weight of an object is simply how strongly gravity pulls on its mass. So if you hold a rock in your hand has to push upward with the same force that gravity pulls downward. That's why your arm gets tired. You are constantly fighting gravity.
Enter the water, a new force appears.
Now, when you put that same rock underwater, something new appears. A force called buoyant force or upthrust. This is the key idea. Water pushes up on objects that are inside it. This upward push is the reason things feel lighter underwater. It doesn't mean gravity disappeared. It means there is now another force acting in the opposite direction. So, underwater, two main forces are acting on the object, gravity, pulling the object down, buoyant force, pushing the object up. Your muscles now only need to fight the difference between these two forces.
Archimedes' principle.
The ancient Greek scientist Archimedes discovered something amazing. The buoyant force on an object in a fluid is equal to the weight of the fluid that the object sounds complicated. But let's make it super simple. When you put an object in water, it pushes some water out of the way. The amount of water pushed away has a certain weight. The water responds by pushing up on the object with a force equal to that weight. That push is the buoyant force. So, if an object displaces a lot of water like a big rock or your whole body, the water pushes up strongly. If it only displaces a little water like a small coin, the upward push is much weaker.
Why objects feel lighter underwater.
Let's break it down with an example. Example, a rock. In air, the rock has only gravity acting on it. Your hand must hold all of its weight. Underwater, two forces act on the rock. Gravity pulling down, buoyant force pushing up. So the rock's apparent weight, the weight you feel, becomes apparent weight equals real weight, buoyant force. If the rock weighs 10 units in air and the water pushes up with a force of 4 units, it will feel like it weighs only 6 units underwater. That's why your arm feels so much relief when you lower something heavy into a pool or a river. The water is sharing the load with you.
Density, why some things float and others sink.
Another keyword here is density. Density equals how much mass an object has in a certain volume. If an object is denser than water, it tends to sink. If an object is less dense than water, it tends to float. But even if it sinks, it still experiences the buoyant force and therefore feels lighter underwater. Example, a brick and a piece of wood. A brick is denser than water. It sinks. But underwater, it still feels lighter than in your hand in the air. In this case, the buoyant force is equal to the weight of the wood. That's why it stays on the surface. Ships, boats, and even massive cruise liners float for the same reason. They are designed so that their overall density, ship plus air inside plus cargo, is less than the density of water.
Why your body feels light in a pool.
When you go into a swimming pool, your body displaces a large volume of water. That water pushes back with an upward buoyant force. Gravity is still pulling you down, but the water is helping carry your weight. That's Why? You can float on your back. You can pick up a friend underwater more easily. Your joints and muscles feel relief. Many people use water for physical therapy. Underwater, your apparent weight is much lower, so everything feels lighter and easier to move. Let's put all the key ideas together. Things feel lighter underwater because of buoyant force. Buoyancy is the upward force that water or any fluid exerts on objects inside it. According to Archimedes' principle, this force equals the weight of the water displaced. Underwater, the real weight of the object is reduced by the buoyant force, giving an apparent weight that is smaller. This is why objects feel lighter, why we float, and why ships don't sink despite being made of heavy materials like steel.
So now you know. Things don't magically lose weight underwater. It's just that water fights back against gravity with a powerful invisible force called buoyancy. From Archimedes' principle to density, from floating ships to your own body in a swimming pool, this same physics explains everything. If you enjoyed understanding why objects feel lighter underwater, don't forget to like this video, subscribe to the channel, and share it with someone who loves science, physics, and curious facts about water and gravity. Comment below. What should we explain next? Black holes, time dilation, or the science of tides? Thanks for watching. And remember, the world is full of invisible forces. You just need curiosity to see them.